Hello everyone, Ismail is here. Today we're going to start 10.3 Modeling Exponential Growth and Decay. You can find all my lessons on alfaramath.com. Now, in this lesson, 10.3 Modeling Exponential Growth and Decay, we can understand the exponential we learned it before. It's the exponential function, which means when I have a times b to the power of x. So this is the exponential function. Now, what is the growth means and what's the decay means? Now, first of all, growth, from its name, growth means we are growing, means if I have a plant, so this plant is growing, which is goes up, which means we can say it's increasing, okay? Now, growth means increasing. How about decay, which is the opposite of a growth? Decay means decreasing, which means we are going down. So decay, we are going down, which is decreasing. Now, this is the main idea of growth, which is we are going up or increasing, and decay, we are going down and decreasing. Now, let's take some examples about the exponential growth and decay. First, let's do some reflection on this graph here. Now, I have the function. This is the exponential function. F of x is equal to 100, 1.1 to the power of x. Now, question number one. Describe the domain and the range of the function using inequalities. Inequalities, you know that the meaning of inequality means bigger than, smaller than, or equal to, or bigger than, equal, less than, or equal. It depends. Now, we have the exponential function in the pink color here in the graph. Now we need to describe the domain and the range for this exponential function. The exponential function, which means the domain and the range here in this function, the domain always, let's start with the domain. Domain is always starting from left to right. Clear? So, sorry, right. This is right. Now from left to the right. So as you can see here, this my functions go from negative infinite forever and goes to the right forever. So my domain is from negative infinite to positive infinite. So this is as interval notation, but he said using inequalities. Using inequalities means I have to do what? I have to do this from negative infinite greater than or less to x greater than or less positive infinite. So this is the inequality. Now, what is the range? The range here in this equation, we need to find the range. We know that the range from down or from the lowest point to up to the highest point. Now, the lowest point, if you remember the exponential function, it starts from which value here? What's the value here? Starting from 0. So now the range starts from value 0 and the close the bracket because 0 is included, and to the power and to infinite, which is go up forever. Now, so start from 0, goes up forever, so that means infinite. Now, if I need to write this one as inequality, you know that range is related to which axis? Range is related to the y-axis, right? So now I have to write y, and my function is greater than what? It's greater than 0. Sorry. So now let me rewrite it again. Now, so the lowest point is what? The lowest point is 0. And we know that this one is in y is greater than 0. So this is the inequality. Now, identify the y-intercept of the graph of the function. Now, what is the y-intercept? This one is the y-intercept, this one here, okay? But because the graph is not clear, let me remove this one to show you what is the y-intercept. Y-intercept is 0 and 200. If you remember, I told you always a to b to the power of x. I told you always when we made the graph, or let's say the table, I told you when it's 0, the first point here should be what? It should be a, and which is this a here, right? Now, if I ask what's a here, it's 200. So the first, it should be 0 and 200. That's what you can see here. Now, an asymptote of a graph is a line the graph approaches more closely identify an asymptote of this graph. So as you can see, line graph approaches more closely. So as you can see here, this my graph is going close from which axis, from which value? From 0 value. So the answer here, for sure, y is equal 0. Now, discussion. Why the value of the function always greater than 0? Y is always greater than 0? Okay, because another positive number, it is impossible for the growth function to go below the x-axis, because as you can see here, because this one is a growth function which is a positive a here is positive number, so for sure my function will go forever and it will not go below the x-axis. So this is just summarize, or let's say, the whole idea of the growth, and the same thing happened with the decay if my function is just an example if it goes like this. Now, let's start here to know what is the growth and decay in this lesson. We have formula. We can use this formula for the exponential. Y equal a times 1 plus r to the power of t. And the decay is y equal a 1 minus r to the power of t. Now you're asking me, teacher, what's r, what's t? Now, as you can see, the difference between exponential growth and decay is the positive. R here is positive. R here is what? Is negative. This one will show you when the decay and the growth function. First, let's start with a. What's a here? A always should be greater than 0, because if a is equal 0, so that's mean 0 times anything here to the power of t is equal what? Is equal 0. So we can't have 0a. Now a means the initial amount. So always if the question tell you the initial amount of selling something is $200, so you have to say that a is equal what? It's $200. Now, 1 plus r or 1 minus r, as I told you, plus r represent the growth and the negative r represent the decay. What is the r? R means the growth or decay rate. So rate means the question can sometimes written in, let's say, the rate, which is percentage, which means 5%, 0.2%, 1.25%. So rate means R is the rate, can be written in percentage. And T, so this is R. And T, which is the last one, is the time interval, which means maybe it can say 5 years, it can say 2, it can say 6 years or 7 months, it depends. Okay, now let's take some examples to understand how we can solve. So the question will say, write an exponential growth function for each situation and graph each function and state its domain, range, asymptote. What does the y-intercept represent in the context of the problem? Now, we need to graph the function, that's the first. Then we need to state the domain and the range and the asymptote. Asymptote always y is equal 0. I will tell you why. Okay? What does the y-intercept represent? Then we need to find y-intercept represent what. Now let's start with the first equation. First question here. The first question, a baseball trading card is sold for $2 and its value increases by 8% each year after it is sold. Find the value of the baseball during a trading card in 10 years. Now, when you need to start, first write the exponential growth or exponential function a times 1 plus r to the power of t, or y equal a 1 minus, sorry, 1 minus r to the power of t. Now we need to pick one of these. Which one I'm going to use? To know this, read the question again. Now, a baseball trading card is sold for $2. It's sold for $2. So we can know that A is equal what? So this is the initial amount, $2. Clear? And its value, what's saying here? It's increasing. Increasing means I'm going to use what? the growth function. So I have now to erase the decay function and let's work on the growth function. Now I have it. Then it's saying increase by 8%. I told you percent represent what? Represent the rate, which is represent R. So we need now to find R. Then, sorry, R is given, so, but here it's in percentage. I need to convert the percentage to a normal number. So now, 8% each year after it's sold. Now, find the value of the baseball trading in 10 years. 10 years, I told you, years is represent the T. Now, let's replace all the value in the function and see what is the answer. But first, let's convert the rate. As we can see here, it's saying percentage. Percentage, the percent means 100, right? So always rate R. When give you rate and percentage, always you put the number over the 100. Over, always like that. 8 over 100. And we know that 8 over 100 is equal 0.08. Now, R is equal what? R is equal 0.08. Now, let's write the question. Y is equal. A is 2. 1 plus 0.08 to the power of t, which is equal 10. Now, if you find the answer of this function, we need to find the answer of this. So, y is equal to, now, let's simplify the thing inside the bracket. 1 plus 0.08 is equal 1.08 to the power of 10. Now, if you use your calculator to find the answer, y time, here in this lesson, you can use the calculator. It's allowed to use the calculator. It's fine. So let's use the calculator. So let's put it here, 2 multiplied with 1.08 to the power of 2. So the answer, you click on SD. So the answer is 2.33. So this one it's 2.33. Okay. Oh, sorry. I forget to put 10. Oh my God. I put 2. Sorry. It's not 2.33. Now let's erase this. Okay. To the power of 10. To the power of 10. Sorry. So the answer is 4.317. So the answer is 4.317. 4.317. Now, after 10 years, find the value of the baseball trading card in 10 years. So after 10 years, he should make the profit, which is 4.317. Now, how can I make the table and see the growth rate, and how can I graph this? Perfect. So the first thing, we need to identify the function. Identifying the function means I have to replace everything except the t. So now this t, I don't have now to replace it. خلاص, ignore it. So we don't have it. Now write the equation without t and keep t in the equation. Now, if I need to write it again here, so the function is y equal a1 plus r to the power of t. Now, replace a and r. Always replace a and r, but t don't replace it. Just keep it as x. So this one is 2, 1 plus 0.08 to the power of t. So the function will be y is equal to 1.08 to the power of t. Now this one is the function that I'm going to use to fill out my table. So t represents like an exponential function. Now, let's start representing the table. So the table, it's 0, 3, 6, 9, because we are talking about 10 years. So starting from 0 years to 10 years here, but because I'm taking the multiple of 3, 3, 6, 9, 12, so it's fine to take more than 10. Now, let's replace the value in the function here. So let's take 0 and replace 0 and replace t. So now it will, let's replace here, replace it 0 in the t here. Now it will be 2 times 1.08 to the power of 0, which is equal what? Equal 2. So now the first point you have to take is the 0 and 2. 0 and 2. So that's the first point. Now, let's test 3. You do the same thing. You have to replace it with the t, so it will be 3 times 1, not 3, sorry, 2, okay, 2 times 1.08 to the power of 3. So you can use the calculator to find the answer, which is equal, uh, let's do this, which is equal 3. So the answer is 2.5. 2.5. Okay, let's say 2.5. Now you can take this one, put them here. So 3 and 2.5. Now let's test number 6. So 1.08 to the power of 6. Also, you can do the same by using the calculator. Now let's replace 3 to 6. Now the answer is 3.17, I think. I don't remember. Let me just remember. So 3.17. Yes, that's right. Now you take this two value and replace them in the table. So 3 point, sorry, not 3. You first take 6, then you take the second value, 3.70. We can also continue replacing 9. So 2 times 1.08 to the power of 9. Then we have 1.08 to the power of 12. Now let's find the answer for all of this. Let me find them fast, which is equal. The first one is 3.99, which is equal 4, just rounded. 5.03, which is 5. So now the first coordinate is 9 and 4. 9 and 4. And here this coordinate 12 and 5. 12 and 5. Now let's plot these coordinates. Now the first coordinate is 0 and 2. 0 and 2. This is the first coordinate. The second coordinate is 3 and 25, 2.5. 3 and 2.5, which is here. Then we have 6, 3.17. 6 is here. Then 3.17, which somewhere here, before above the 3 a little bit. Then we have 9 and 4. Then we have 9 and 4, which is here. Then we have 12 and 5. So 12 here, 5 is here, right? Now, if you check my graph is increasing, increasing, increasing. As you can see here, this one is what? This one is a growth, okay? Which growth function increasing. So as you can see here, by the 10 years or around 10 years, he's growing up and taking the answer. Now, let's find the answer, which is the domain. The domain here, it starts from, as I told you, the domain starts from left to the right. So from left to the right. So left is, what's the value here? It's 2. 2 words goes forever to infinite. Now I can write it 2 from 2 less than or greater x, not y, sorry. 2 less than x. Now, oh, sorry, not 2. This is 2 value is the y-axis. Sorry, sorry, sorry. It's not 2. We are talking about x. This is, yeah, I know this is 2, but we are talking about x-axis. So on the x-axis here is infinite, but on the x-axis here, what's the value on the x? It's 0. So from 0, okay, from 0 to infinite, which is from all the value greater than 0. Now, the second one is the range. The range is from down, or which is the lowest point, to the up, or the highest point. Down, what is the lowest point here? The lowest point is what? On the y-axis. So the lowest point is 2, and it goes up forever, which is infinite. So 2 to all the value greater than 2. Okay, so all the value greater than 2. Now, what is the y-intercept? What is the y-intercept? So this is the y-intercept. Y is equal what? Y is equal 2. This is how we can solve the questions by finding the value after the 10 years. Then we can find the values or watch the growth after creating the tables when we do the equation. Now, we have here some fast example. Let me just explain it very fast. So a painting is sold $1,800 and its value increasing 11%. 11% means 11 over 100. So this one is R, right? Always over 100. So it will be 0.11. Now, each year after it's sold, find the value of painting 30 years. So T is equal 30. Now I have A, which is 1,800. I have the rate 0.11. I have the years. So now let's use the growth function because here it's saying increase. Increase is a growth, not decay. So now 1,800 times 1 times 0.11, which is R. Then we multiply them. Then we have the function. Then we can replace the T, which is equal 30. So now we can find 41,206. For sure, in this lesson, you will find the big numbers. Big numbers because we are talking about the profit, money, and 2,200, 1,000 million, 2 million, 3 millions. It's up to you. Now make your table. So pick the value because it's just pick value, random value, just 5.08, 16, 32, 30, 6, 24, 32. Now this value, you have to plug this value in this function here. Okay, you have to plug this one in this function. So now if I need to plug it, 1,800 times 1.11 to the power of 0. Then here 1,800 1.11 to the power of 8. Then here 1,800 1.11 to the power of 16. 1,800. Then you can continue, you know that process. Then after that, I have the coordinate after I found them. Then I can plot the coordinate. This is the first one, the second one, third one, fourth one. Then you can connect between the points. And this one is the growth function. Now, if I ask you what is the domain, so the domain from left to the right, so the left is equal from 0 to infinite, and from left to the right, and the range from down to up. So down is the value here. The value here is 1,800, which is A. Okay. So now all the value greater than 1,800. Now, here are some practicing questions.